so the first thing we're going to do is we're going to set up our test tubes, including our standard curve from the known egg albumin concentration, and we're also going to set up our blank to blank the spectrophotometer. So first thing I'm going to do is I'm going to add 0.1 mils or 100 microliters to the blank, and then test tubes 2 through 6 so that we're set up for our serial dilution. So now we're going to use the known egg albumin solution for our standard curve, and the albumin has a concentration of 4 milligrams per mil. So typically proteins have units of concentration of milligrams per mil or milligrams per liter. The second test tube already has 0.1 mils of water. So now we have a total of 0.2 mils in the second test tube. We want each one of these test tubes to have a final volume of 0.1 mils. So we're going to do a serial dilution. So I'm going to use the pipetter to mix the solution a little bit, and then I'm going to go from most to least concentrated by doing a 1-in-2 serial dilution. So I'm going to half the concentration each one of these test tubes by mixing and taking 0.1 mils from each test tube and going from 2 to 3, 3 to 4, and 4 to 5. Each one of these test tubes already has 0.1 mils of water. Alright, so now I'm mixing each one of the test tubes. So I draw some solution up, shoot it back in, because we are diluting from an initial stock in series. So each step we're halving the concentration. So make sure that's well mixed. So same thing, still doing a 1-in-2 dilution. Yes, so we're mixing each one of the solutions within our test tube. So when I draw up the solution into the pipette and shoot it back, we are mixing the solution, making sure it's homogeneous. So well mixed. So now for this last one, we still want to make sure we mix the solution, but we want the sample matrix to be the same for each one of the test tubes. So we have 0.1 mils of solution in each one. This final one has 0.2 mils because there was 0.1 mils of water in there. So we want to draw up 0.1 mils, and we're just going to discard it to the waste. So now each test tube has 0.1 mils of solution in there before we add the Bradford reagent. Alright, so now we're going to pour the Bradford reagent into a secondary container. We need about 40 mils. Five mils. So we're going to put 5 mils of the dye. That's what creates that the change in the wavelength, the binding with the dye and the protein. So I do about 5 mils. I'm going to start with the blank. So we want to put 5 mils of the Bradford dye into each one. Probably should have put a little bit more Bradford in the beaker.
Nice one.
So now we need to let our solution sit for 5 minutes so we can allow for that protein to dye interaction. So we want to make sure each one of the solutions, including the blank, has about 5 minutes for that to happen. Waiting for that protein dye interaction in our standard, we are going to prepare our unknown albumin concentration samples. So in the procedure for the lab, it says you can get your absorbance for the unknown egg albumin on your own, and then you grab 2 other lab groups samples. So instead, we are going to do 3 unknown egg albumin samples and still do our standard deviation. So we have the micropipette set at 100 microliters. This is the P200. So we're doing 100 microliters in each sample. So now we have 0.1 liters or 100 microliters in each one of those test tubes. Now we need to add the Bradford reagent, the Bradford dye. Now we add 5 mL to each. All right, so now we are going to do the same thing, and we're going to allow that dye to interact with the protein in our unknown samples. So we're going to wait 5 minutes. What you'll notice also, it happens when we are constructing our standard curve for part 1 as well. The test tubes are all made differently, so they do all have the same volume, but they are different sizes. So that's why you'll see a little bit of a difference in the volume. All right, so first thing we need to do is we need to blank the spectrophotometer. So here's 0.1 mils of DI water, or 100 microliters of DI water, with 5 mils of the Bradford reagent. So now we blank the instrument. All right, so now let's record the absorbances for each one of our solutions. Now we're going to start with test tube number 1, which was our stock. So this first one would have been the 4 milligrams per mil. All right, so our first absorbance is 1.258. All right, so now each one of the test tubes from here, we're going to go from most to least concentrated. These were all done with a 1 to 2 serial dilution. So you guys will need to figure out the concentrations on your own. Number 3. Next one, number 6. All right, so now we're going to record the absorbance for each one of our unknown egg albumin samples. So we'll take out test tube number 6. Now we'll start with our first unknown egg albumin. Last unknown. So now we are going to do the dilution for the non-fat milk. So we're going to determine the protein concentration in the non-fat milk by dilution. So for this part, we want to make sure we're within our linear range of the standard curve, which basically means in between our highest and our lowest recorded absorbance, where we have a linear response. So the first dilution I'm going to do is going to be a 1 in 5. First one will be a 1 in 5 dilution. So we're going to start with the P200 micropipette, use 100 microliters. So it's 0.1 mils, or 100 microliters of the non-fat milk. Now 400 microliters of water. So now we have a total of 0.5 mils. So now we're going to mix our solution. Now we're going to take 0.1 mils and put it in our second test tube for the 1 in 5 dilution. So we still want to have the same sample matrix where we have 0.1 mils of solution and then 5 mils of the Bradford reagent. Alright, so now we're going to do a 1 in 10 dilution. So that way we have a 1 in 5 and a 1 in 10 in case our 1 in 5 dilution does not fit within our linear range. So we're going to use 0.1 or 100 microliters of the non-fat milk. And now we are going to use 900 microliters of DI water. Now we're going to mix. Of our 1 in 10 dilution and put it in our second test tube. So now both of our dilutions are ready for the Bradford dye. So now we're going to add 5 mils of the Bradford dye to each one of our non-fat milk samples. And now we're going to let them sit for 5 minutes. Alright, so now we're going to record the absorbance of the non-fat milk, the protein content in the non-fat milk. We'll start with the 1 in 5 dilution. Just outside our linear range. So our highest absorbance was 1.258. This is 1.593. So it's not within our linear range. So now let's check the 1 in 10 dilution. Alright, so we're still a little high. So our highest was 1.258 and the 1 in 10 is 1.267.
So we have to go with our next dilution.
Yep. Alright, so the 1 in 10 did not fit within our linear range, so we're going to do a 1 in 20 dilution. Alright, so 100 microliters. Now we add 1.9 of DI. Now we need to grab 0.1 or 100 microliters of our 1 in 20 dilution now. And add 5 mils of the Bradford dye. Now we wait 5 minutes. Alright, so it looks like we have an absorbance of 1.029. So don't forget, this was diluted by 1 in 20, a factor of 20.